Hello, my name is John Horgan. I'm a science writer. I teach at Stevens Institute of Technology. I've been talking to people about science for a really long time on here on Blogging Heads TV / Meaning of Life TV / Mind Body Problems. I guess that's my personal website. And lately, I've been talking to people about quantum mechanics because I'm about 7 or 8 months ago, I decided I was going to try to learn quantum mechanics for the first time. I've been writing about it, pretending that I know something about it for decades now, but in a kind of hand-wavy English major kind of way. I actually was an English major. So now I'm struggling to learn it in the way that physicists learn it. And so I've spoken to a couple of people just over the last month or so who've written books on quantum mechanics. And with me today is, I'll just let you introduce yourself briefly, Adam, and then I'll tell everybody. I'm sure you're going to be modest. I'll tell everybody how great you are.
Sure. Yeah, no, I can tell the truth and you can lie. That'll work well. Hi, I'm Adam Becker. I am a science writer and physicist. Physicist by training, science writer by vocation. And I am an author. I wrote a book called What is Real? The Unfinished Quest for the Meaning of Quantum Physics. And I before I was a science writer, I did my PhD in physics at the University of Michigan. After finishing that, I've gone on to write for a bunch of different places about a lot of different things in physics and quantum mechanics.
Yeah, you're like a nightmare for science journalists like me because you actually do know what you're talking about, and you're a really good writer.
Thank you.
So, if there are more people with PhDs in science who had your kind of writing talent, that would really be a problem for folks like me. So I'm going to hold up your book, What is Real? I read it. It's been a while now. I think maybe it was more than a year ago, maybe a year and a half ago. I read a review by Tim Maudlin, philosopher of physics, who is a tough guy.
Yes.
He can be very hard on people.
Yes, he can.
He wrote, I think it's fair to say, a rave review of your book for, was it like the Boston Review of Books or?
Yeah, it was the Boston Review. Yeah.
Yeah. And so it had sort of been on my list, my to-do list for a while, but then I got down and read it. And it was everything that Maudlin had said it is. He had his own reasons for loving your book, and we'll get into that. But it's a really great history of quantum mechanics. I've read a lot of histories. I've talked to people about quantum mechanics quite a bit. I've read a whole bunch of books to try to prepare myself for writing about it. And you told me a lot of things that I didn't know. And within this kind of narrative that made the quest to discover quantum mechanics and then explain it really exciting, really dramatic. And you did a great job bringing in all the familiar characters like Bohr and Einstein and David Bohm. These really some of whom are very fascinating personalities, and also explaining the science in a way that I could grasp. And so I just want to tell you that I really appreciate that. And if any of you out there who are watching this want a kind of introduction to the issues of quantum mechanics that are not hand-wavy and not overly dumbed down, but are good enough even for a serious player like Tim Maudlin, then you should definitely check out this book.
Thanks, Joe.
Okay, so now before we get to the gist of the book, I'm curious. you got a PhD in physics. You did, you were interested in astrophysics and cosmology. I think your PhD, your thesis was on cosmology.
Yes.
Why then did you make the decision not to become a full-time physicist and try to get an academic position? I'm curious about that.
Yeah, that's a good question. My usual glib answer to that is, the academic track has, a long path involving, low pay and bad job security. And before you maybe get to the very rare prize of tenure, which is, you have a low chance of getting that even if you're a great physicist. And so I looked at that and said, well, low pay and bad job security, I can provide that for myself. Yeah, exactly. Now I'm a writer. I get to live where I want to, which you don't get to in academia. But yeah, the longer answer is, I really enjoyed doing physics research, but it didn't feel like something I wanted to do in the long run. I was reasonably good at it, but I wasn't great at it. I enjoyed it, but I really found that I didn't have the kind of monomania necessary to pursue, just one or two research projects for years and years on end. And I really liked talking and writing about science. And so I thought, okay, well, rather than being a physicist, and, trying for this academic track that probably won't work out anyway, given the nature of the academic job market, why not go somewhere that is at the intersection of my skills and see if I can make more of a mark there and have more fun.
And you're fortunate that, I assume your book did pretty well. It got a lot of good reviews. And this means, of course, that you're more likely to get a decent amount of money for your next book. But let me just ask you something.
Sure.
A question that's come up in the course of my trying to understand quantum mechanics and talking to a lot of physicists and physics students about it. I even took a course at my school, Stevens Institute of Technology, an Introduction to Quantum Mechanics course. It just crushed me. It was way too hard. But did your physics education, was it unsatisfying in the sense that it didn't meet your expectations as far as sort of, getting to the big questions posed by physics and some of the philosophical issues? I'm getting this complaint from a lot of the people that I've talked to that some have pursued their interests in the big questions posed by physics in spite of their education rather than because of it. And I'm just wondering what your experience is.
Yeah, no, that's a really good question. When I was in college, I studied philosophy as well as physics, in part because the physics department was not answering all of the questions that I had about what was going on. And in particular, it was very frustrating when I got to my quantum mechanics classes. So yeah, no, it's definitely true. Is definitely true, especially in early physics classes in a university course, that there's a lot more emphasis on how to do physics and a lot less emphasis on what it is that we're doing when we do physics and why we're doing physics. So, the deep questions about things like, okay, well, what's in the world and what does physics tell us is in the world, are questions that sort of get brushed to the side and then sort of get answers later on, but not really. When I was in college, the physics department was doing a very smart thing, but they didn't execute it particularly well. They realized that the first few semesters of the introductory physics sequence were kind of maybe not the most exciting physics classes. And so they said, okay, well, let's put together a sneak preview class where we go through some of the fun stuff that shows up in the later physics courses in like a qualitative way with a little bit of math. To sort of say, okay, look, if you stick through the introductory physics sequence, this is what you have to look forward to. And we'll just make it like 1 credit, pass, fail, something that, you know, even ambitious freshmen can add on to their course load without too much trouble. And so, so they did this, and I took that class, and the way in which it was poorly executed was the professor doing it was not great. And I ended up getting into some sort of debate with him. I don't remember the details because this was more years ago than I want to think about. But you know, he was saying something along the lines of, you know, we can't talk about what's going on in quantum mechanics when we're not doing a measurement. And I asked something along the lines of, well, what do you mean by measurement, or what's happening when we're not looking? Why can't we talk about that? And I don't remember how it went back and forth, but I remember it escalated to the point where he said in this very haughty, dismissive tone, well, if that's the kind of question that you're interested in, then why don't you go to the philosophy department? And I just sort of, you know, I don't remember what my response to that was, but I remember thinking, well, I already am. You know, I already went to the philosophy department, and they're giving me better answers than you are, buddy. So yeah, no, it is definitely a problem that certain questions just sort of don't get answered and are even in some cases actively discouraged. I mean, and I don't think that it's any sort of like coordinated effort. It's just that, you know, this is the way that we're trained to do physics. And, you know, the questions that we can answer quantitatively or with the methods at hand are the ones that we focus on when we do physics.
Would you say, is that the seed from which your book grew?
Yeah, I think so. I mean, there's a lot of different things. Like, you've written books. Books don't come from one place. Books come from a lot of different places. But that was certainly one of the formative experiences that led to the book, for sure.
Because it sounds like, I mean, you know, there's this common phrase. I'm not sure who first coined it. Maybe David Merman, shut up and calculate.
Yeah.
And the idea is that you learn the formulas of quantum mechanics. You learn these techniques, and then you apply them often in doing, I don't know, various kinds of experiments that might lead to devices. And it's very practical. Yeah. And these deep philosophical questions are like, what is a measurement anyway, which you were posing to your professor, are seen as distractions.
Yeah.
From just sort of becoming this automaton that can apply this knowledge to do various things.
Yeah. And I mean, I can understand why that's the approach. I mean, because that's definitely what's going on in a lot of introductory quantum mechanics classes. And you're right, as far as anyone can tell, the first person to say shut up and calculate was David Merman. But he was trying to describe this approach. You know, it wasn't prescriptive, it was descriptive. Right. When he said that. And
disparaging.
Yes. Yeah. So you know, in defense of shutting up and calculating for a moment, it is absolutely true that when you learn any computationally or mathematically complex subject, that sometimes it can be important to say, look, I know you have these questions, hang on to them, just put them aside for a moment. We're going to get down to the nuts and bolts of how to use this thing. And then once we know how to use this, you know, mathematically complicated set of equations, we can come back to that question with more knowledge and more tools at hand. But it's that last step where most quantum mechanics courses kind of fall down. They say, okay, yeah, I know you have these questions. Just put them to the side and then pick them up from the side and put them in the trash. And then, you know, just leave it out on the curb and don't think about it ever again.
Right. Okay. One more question. And then I promise we'll get to the substance of your book. Sure. I'm curious, you know, because I'm I'm in the middle of this project to try to understand quantum mechanics with the mathematics. I spent last summer trying to relearn calculus, which I took more than 40 years ago, just 1 year, to learn linear algebra for the first time. I had to try to relearn logarithms and trigonometry, and oh my God, trigonometry is always has always been a pain in the ass to me. So the question I have for you is, and you have the mathematical training. To what extent is the mathematical training really helpful to understand the philosophical issues arising from quantum mechanics and to reach judgments about those philosophical issues?
So those are sort of two separate questions. So I'm going to tackle the first one first. So I'd say the good news is that it's not that computationally or mathematically intense to get a good enough handle on quantum mechanics in order to really understand some of the important foundational issues. Mm-hmm. Of course, it's all relative, but it's easily something that a college sophomore physics student can get their teeth into without too much trouble. Right. It's like you said, you need calculus, some linear algebra, a good handle on algebra and pre-calculus, like trigonometry, and some reasonable knowledge of differential equations. But even that, you don't have to go too deep into it. And that's about it. It's all stuff that gets covered in, advanced high school and freshman level, college math courses. So yeah, once you have that, it's a matter of, learning the notation and sitting down and working your way through some of the issues. The basic stuff is stuff that you could understand after taking the mathematical prerequisites and then one semester of quantum mechanics, and then you can get to the heart of it without too much trouble. And indeed, this is something that is taught to philosophy graduate students on a reasonably regular basis who don't have, too strong of a mathematical background. But to actually dive into it and, pronounce judgments on it and figure out, okay, this is what I think, or this is what I don't think. That I'd just say, the deeper the background and the more math you have, the better. There's almost no limit there. There's stuff that I don't fully understand, and I've got a PhD in physics. But yeah, if you want to, you can dive into quantum field theory, which is, an advanced graduate level thing, and involves, much different and more complicated math. My grasp on that is shakier than I'd like. But you definitely don't need to understand that if you just want to understand, okay, what do people mean when they say the quantum measurement problem? What do people mean when they say, spooky action at a distance or Bell's theorem? That kind of thing. Yeah. One semester of quantum mechanics and, a little linear algebra and calculus, and you'll be good to go. Yeah.
So here's because, I've always been an outsider listening to what people say and trying to understand as much as I can without understanding the mathematics. And I have reached judgments, maybe. Yeah. I've had lots of opinions, which means I basically like the way one person argues for one particular model.
Sure.
To what another person is arguing. But it seems to me that if you expect the mathematics to constrain the philosophy somehow, that clearly is not happening, because you've got all the people, including physicists and philosophers with quite a bit of mathematical background, like David Albert and Tim Maudlin, who are reaching completely different opinions on what's really going on with quantum mechanics. So this is one thing I've become really interested in just recently, is what is what role does mathematics play in this whole philosophical debate over quantum mechanics, and whether it's just another complicating factor or whether it really is kind of steering us towards some particular point of view.
Interesting. Yeah. I mean, I definitely think that what the math does, it lays out the available options, right? Like if you're going to come in and say, oh, well, you know, I have all of this qualitative knowledge of quantum mechanics, but I don't know any of the math. But based on, you know, what I've heard, would this be a reasonable proposal? And then, you know, you sit down and try to understand what that would mean mathematically. And first of all, you realize, oh, wait, no, I can't even make a proposal without understanding the math. Right. But then if you come in and say, okay, well, what about this? And, you know, actually sit down and do the math and find that it violates the Schrodinger equation in, you know, known situations where we know it applies, well, then you're out of luck. Because, you know, we've seen that work really well in basically every laboratory setting. So yeah, I mean, there's all of the different ways of interpreting what quantum mechanics is telling us are very strange. But they're strange because that's where the math forces us to go. Right. But it's a question of, okay, well, what kind of strangeness do you want? You know, one of the things that you'll hear sometimes from physicists who want to just shut up and calculate, which is certainly not all of them. But one thing that you'll hear from them sometimes is, oh, well, you know, quantum mechanics just tells us that the world is really weird, and the people who have, you know, concerns about quantum mechanics just can't accept that the world is weird. And, you know, my response to that is basically, well, have you read anything in the philosophy of quantum mechanics or the foundations of quantum mechanics at all? Everyone knows that it's weird. It's just a question of in what way is it weird?
Right.
Yeah. Weirdness isn't the problem.
Yeah.
Yeah.
And sort of, it's kind of like pick your weirdness. You can solve one problem and then another one gets bigger as a result of. Okay. So, your book, what was your motive for writing like a popular history of quantum mechanics? Did you go in with like wanting to reach a particular conclusion, or did that happen in the course of writing the book?
Yeah, that's another good question. I'd say the only real conclusion I went in with was that the idea of seriously shutting up and calculating has just never been satisfying to me, because there's a serious problem. You know, the measurement problem is a real problem in quantum mechanics, and just, you know, brushing it off by saying, yeah, whatever, the math works, that's not satisfying and is also like questionably logically coherent, especially because, you know, you need to have a way of resolving the measurement problem just as a practical matter in order to use the math of quantum mechanics. And then if you take a look at the actual practical way that it's usually solved, that method of solving it, which basically says, oh, big things don't, you know, aren't quantum, that completely belies all of the stories that we tell about quantum mechanics as a kind of underpinning of the everyday physics of you know, the familiar world of, you know, medium-sized dry goods. So that's a real problem. And that was a lot of my motivation, was that, you know, this was a problem. It's a problem that had bugged me for a long time. And there are a lot of popular books out there about quantum mechanics, and almost none of them tackled this thing in the way that I wanted to see it tackled. And in particular, one thing that was really strange to me was the status quo in physics, the fact that the usual advice is to shut up and calculate. And I was just bewildered that that was the case, especially when, you know, as a physicist, I like symmetries, right? And if something's not symmetrical, I want to know why. Well, the philosophers of physics know their physics very well, and they listen to the physicists very carefully. but the physicists don't listen to the philosophers at all. So there's a broken symmetry there. And I wanted to understand, okay, why is it that the philosophers know plenty of physics, but the physicists don't seem to know any philosophy? And in particular, when asked to defend their views, physicists will often rely on outdated or discredited or just flat out bad philosophy. If you say, well, why can't you talk about what's happening when you're not looking? One answer that you'll often get is, oh, well, what's happening when you're not looking is something that's in principle unobservable, and so it's not meaningful to talk about that. And that is, at worst, that's just incoherent. And at best, that is relying on a very, very outdated sense of philosophy of science, and thoroughly discredited ideas from 100 years ago. The kind of thing that a philosophy undergraduate can just knock down with, stuff that they find in a textbook that's 50 years old. So, that was just an astonishing state of affairs to me, and I wanted to understand where that came from. So that was a lot of my motivation for the book. And
you, is it fair to say you blame Nils Bohr for a lot of this? He's kind of the villain of your book, right?
Yeah, I struggle with this. On the one hand, yeah, if there's a villain in my book, I suppose it's Nils Bohr. Although I don't know, Heisenberg comes off pretty bad in the book too, arguably worse. But on the other hand, do I blame Nils Bohr for all of this? Not really. I want to. Could he have done better? Sure. Was he a brilliant physicist, and is it hard to fault him? Yeah, I kind of think it is. I mean, I always want to be sympathetic to physicists in history who are struggling to deal with a theory that is new to them that is not new to us, right? Because hindsight is 20/20. I mean, of course, we know more about general relativity now than Einstein did. And that's not, bragging. That's just a fact about the world, because we've learned more about it than Einstein did, because it's been longer and more people have worked on it. We know more about quantum mechanics than Niels Bohr did for the same reason. So do I lay the blame on Bohr? Bohr certainly bears some of the blame. But it's also true that Niels Bohr has been dead for a really long time, and yet the problem persists, so it can't all be him.
Yeah, the culture has carried forward some of his ideas. The way I think about Bohr, and you tell me if this is more or less right, that he was sort of saying that we shouldn't worry too much about the metaphysics, that we have these methods that are working extraordinarily well at explaining the results of experiments and suggesting new experiments that then are further confirming the theory and leading to its kind of expansion. And he was basically saying, just don't worry about the measurement problem and the weird fact that sometimes an electron looks like a particle and sometimes it behaves like a wave. And my understanding is that he was adopting some of the philosophical views of the time, which were sort of positivistic and sort of anti-realist. Don't science really isn't in the business of telling us exactly what's out there and all that kind of stuff. Is that fair to say that?
Yeah, I mean, I'm going to give you another wishy-washy answer. I am very wary of ascribing any particular view to Bohr, because Bohr was not great at expressing himself. And this is one of the few things that people seem to mostly agree on about Bohr.
That was like the comic theme of your book.
Yeah.
Nobody really knew what the hell he was talking about, but everybody thought that he was like Yoda. He was just this font of wisdom.
Yeah, exactly. Who's clearly, someone with great force of personality and charisma. I think it's David Albert likes to say that, he's one of the figures from history that he'd most like to meet, because apparently being in the actual presence of Nils Bohr was this very special and difficult to convey experience that was profound for so many people. It's certainly fair to say that what you just ascribed to Bohr is something that many other people have ascribed to Bohr. Whether that's what Bohr actually thought, there are a lot of different positions that people have ascribed to Nils Bohr. On the one hand, there are things that you can point to in Bohr's writing where you can say, well, that's not positivism at all. I think he's even said at one point that, he wasn't being positivist. But on the other hand, there were positivists who, wrote to him at the time who said, really seems like you're saying stuff that's very similar to what we're saying. And he replied saying, yeah, that's right. So it's hard to make sense of it. As you said in my book, one of the running themes is that it's difficult to tell what Bohr was, saying and what he meant. And so what I ultimately settled on was, okay, well, if nobody was really sure what he meant, then what mattered more than his actual position was what people took him to be saying. And it's certainly true that people either took him to be saying that we don't need to worry about the measurement problem, or that he had somehow resolved the measurement problem, and so everything was okay.
Right.
Yeah.
Well, so I wanted to make sure we get to, of course there's Einstein. We could talk about him for hours, but if Bohr is, with all the qualifications that you stated, the villain of your story, I'd say that the hero is, apart from Einstein, he's always the hero, but let somebody else have the spotlight for a minute, and you shine the spotlight on David Bohm, who's a fascinating figure. Was that deliberate on your part? Were you trying to give him recognition that you felt he deserved as a serious interpreter of quantum mechanics?
That's a good question. Yes, I think the short answer is mostly yes. The longer answer, as I said before, there are a lot of books out there on quantum mechanics and the history of quantum mechanics. And so one of the ways that I sort of pitched this book to my agent and to my publisher, and sort of the way I was thinking about it was, most books on quantum mechanics that take a historical approach sort of start with, stuff in the very late 1800s or early 1900s, like Max Planck maybe the discovery of X-rays or something like that. And then, they finish up around 1927, or maybe they go to 1935. And then there's maybe a chapter at the end about everything that's happened since World War II. And I said, I want to take that structure and invert it. In my book, Bohr and Einstein will be dead by chapter 3, which I didn't quite manage to accomplish, but they were mostly off the stage. And then, devote the rest of the book to all these other figures. So Bohm specifically, yes, but also Bell and Everett, who I thought, the three of them are people who sometimes get mentioned at the end of quantum mechanics books, but not for very long. Bohm in particular is someone who I think has been forgotten by a lot of physicists. If you say to physicists, have you heard of John Bell? Most physicists have heard of Bell's theorem, which certainly wasn't true, 30 years ago, but I think it's true now. If you say, have you heard of Hugh Everett? Fewer physicists have heard of Everett, but there's still like a good number of them who say, yeah, didn't he come up with the many worlds interpretation or something like that? If you say, have you heard of David Bohm? Unless they're the sort of people who are in the habit of, following up on the references in the back of their undergraduate physics textbook, they're unlikely to have heard of David Bohm. So yeah, I definitely wanted to bring all three of them to the front, but Bohm in particular seemed like somebody who just, hadn't had a lot of light shined on him before. There was that, there's a guy I know, a friend of mine, who knows a lot more physics than I do. He's a string theorist, and he read my book and he liked it, and he and I were talking about it. And he said, that whole David Bohm thing, I'd never heard of any of that. It was just fascinating. And I said, well, I'm glad I was able to tell you about it, but it's nothing new. It's been around for a long time.
I felt like if you were that if you were forced to choose between the various interpretations of quantum mechanics that are sort of bandied about these days, that Bohm's pilot wave model would be your favorite.
Oh, that's really interesting that you say that, because I've had people tell me that, but I've also had slightly larger number of people tell me that they read my book and came to the conclusion that Many Worlds would be my favorite. And so I'm just fascinated by this, because, my answer is I go back and forth between those two, and also some of the collapse theories, and also just being dissatisfied with everything. Like, I sort of sat down to write the book. This goes back to an answer to an earlier question. I sat down to write the book and said, okay, I really don't like this sort of vague nonsense called the Copenhagen interpretation, but otherwise I don't feel like I have a real horse in this race, and I should probably maintain that position as I write the book, because that will make for a better book that does, that does better by the reader. And so I sort of maintained a kind of professional agnosticism. And then when I finished writing the book, I was surprised to find that had turned into something a little deeper, where, now I feel like, okay, my favorite interpretation is none of the above. And, but in particular, I don't think that Copenhagen is even in the running, because it's not a real interpretation. Yeah.
Let me say, so it seems to me, okay, I wanted to, I was hoping that you would give me a few sentences describing Bohm's.
Oh, absolutely.
But okay, maybe, yeah, go ahead and do that, because I'll just tell you, I interviewed David Bohm in the early 90s. I spent 2 or 3 hours with him at his home, trying to get him to explain his views of everything, spirituality as well as physics. I found him, and I'm not alone in this, I found him at some points crystal clear, just absolutely eloquent, and I understood exactly what he was meaning. And then a moment later, I didn't know what the hell he was talking about. And I went back over the tape, and it was like word salad sometimes. So I spent a lot of time, I wrote a big profile of him for, I think it was Discover magazine. And then I had a section in my first book on him. I really tried hard to understand the pilot wave theory, and I feel like I still don't really understand it. So let me just tell you what I think it is, that there's this whole question over what a wave function is. And it's sort of this mathematical object that you can use to calculate the probability that an electron will be in a certain place at a certain time. Then you make a measurement, and here it is in one of those places that the wave function was saying it might be. But Bohm is saying that the wave function is a real physical thing, that there is this wave that is somehow moving particles around in a complicated way. So how is that right or wrong? Or
yeah, that's not quite it. Before I dive into this, I should say I don't want to say that this is what David Bohm thought, right? Because David Bohm's views, especially toward the end of his life, are very complicated, and I am not an expert on them. And the other thing is, the thing that we call pilot wave theory or Bohmian mechanics, or whatever you want to call it, is largely based on these papers of Bohm's from 1952 when Bohm was fairly young. And it has been taken in several different directions. So like even now there are disagreements among the people who subscribe to Bohm's ideas about how to interpret them. So like one of the things I fudged in my book is I said, okay, here are 3 different ways of interpreting quantum mechanics. They're not the only ones, but they're 3 big ones. And the actual truth is actually those are 3 categories of interpretations. Within each of those, there are several different options, and in some cases, many different options. Mm. But one way to understand pilot wave theory is to say, okay, it's not that the wave function itself is real, because the pilot waves that show up are not exactly the same thing as the wave function, but they're similar. They're closely related. One way to think about it is to say, okay, you've got all of these experiments that seem to show that the tiniest little bits of matter and energy in nature have a particle nature, and then other experiments that show that they have a wave nature. And so Bohm's answer is to say, well, then it's both. It's particles and waves. It's particles guided by waves. And so there are waves that are associated with each particle, and these waves behave like waves guided by a wave equation, and then those waves in turn influence the motion of these particles that are associated with them. Now, it gets more complicated than that when you start dealing with things like entanglement, because then you start to see, the wave for one particle is instantaneously influenced by the position of the second particle. And so, then the question is, okay, well, should we think about these as little waves, each associated with individual particles, or should we think about it as one big wave and one big particle living in a really high dimensional space that describes the configuration of the entire world? And this is an open, subject of debate among Bohmians. But particles guided by waves, and those waves are related to but not identical to the wave function.
Okay. So let me see, how much time do we have left? It's interesting to me that you said that you're open-minded about the many worlds interpretation.
Yeah.
Can you make a defense of that? I reviewed Sean Carroll's book on the many worlds hypothesis, and I was pretty mean. It's like, come on. It's just got so much metaphysical baggage it's carrying around with it. It just seems absurd to me. What can try to persuade me that the many worlds hypothesis is really cool?
Yeah, I know that's a tall order. Especially if Sean couldn't do it, right? Sean is this, he refers to himself as a mad dog Everettian. He's definitely got a horse in this race. He's chosen what team he's on. And I like Sean. I have a lot of respect for him and his views, even though I don't always agree with him. But if I'm going to pretend to be an Everettian, okay, so if you're concerned about the metaphysical baggage, you really shouldn't be. I want to be clear here. I'm putting on my Everettian hat. I'm putting on my many worlds hat and pretending to be like a full-throated advocate of many worlds here. So if you're concerned about the metaphysical baggage that comes along with many worlds interpretation, you really shouldn't be. That's not a big deal. There are many, many theories in the history of physics and science that have come with a great deal of metaphysical baggage that we nonetheless accepted and now, generally believe to be true, right? If you believe that the Earth goes around the sun and the sun is a star just like other stars, which, we learned in, the 15 or 1600s, and if you believe further that our galaxy has hundreds of billions of stars in it, and is just one of many, many billions of galaxies out there, which is something we learned in the early 20th century, well, then you're committed. And if you then say, and most stars have planets going around them, which is something we learned in the late 20th and early 21st century, well, then you're committed to the idea that there's just a phenomenal number of planets out there, and all these planets have rocks on them, and every rock is composed of, moles upon moles of molecules. And so there's just a vast amount of stuff out there that you're just sort of automatically committed to, even though you're never going to get an electron microscope up close and personal on a rock, with a rock on a galaxy that's, 100 million light years away. But if you say to me, hey, Adam, do you think that there are rocks made of, elements in the periodic table of elements on planets in, going around stars in this galaxy that's 100 million light years away? I'd say, yeah, sure I do. Of course. It's so silly to suggest that that's not true that I'd ask you to defend that to me, right? It's just a consequence of this stuff that we believe is true, to the point where we'd say, sure, that's complicated, but it'd be even more complicated to say that it's not true, because it comes out of these ideas that we just have really strong belief in and really good empirical reasons to believe. So the many worlds interpretation can be kind of like that, right? You can say, okay, yeah. You could say, look, the Schrodinger equation, and the relativistic extensions of the Schrodinger equation that you find in quantum field theory, we've never seen violations of these things. These are equations that seem to always work. And sure, we have this procedure for getting probabilities out of the mathematical objects that they talk about. And this procedure, here at the end of this videocast, we're going to finally talk about what the measurement problem is. This procedure, known as the Bohr rule, is in stark, contradiction to the Schrodinger equation. So you have to know when to use one and when to use the other. Isn't it just simpler to say, so the Schrodinger equation's just always true? The Schrodinger equation's always true, and we just use the Bohr rule when we want to get, probabilistic predictions out of this massive wave function of the universe that we are just one tiny component of.
I think Sean would be proud of that defense of many worlds. You sounded like a true believer.
I'm not.
You could have fooled me. All right, so let me, we've got not that much time left. So I want to get to some of the big overarching issues. Yep. What about, it seems to me that your commitment, if you're not committed to many worlds or to pilot wave interpretation or, to some of these other alternatives that are out there, you are committed to the idea that there is a correct way to look at quantum mechanics. That at the end of all this investigation and debate, we will figure out what this theory is telling us about reality, that the question posed by your book, what is real, will be answered. Is that your commitment? Is that fair to say?
I'm committed to the first thing you said. I'm committed to the idea that there is a right way to understand quantum mechanics. I'm not necessarily committed to the idea that we're ever going to find out what that is. I have hope. I think there's good reason to believe that we will, if we don't find the right way of understanding quantum mechanics, that we will get a lot closer and narrow it down a lot more than we already have. But I don't, here's what I'm committed to. What I'm committed to is that there is a world with stuff in it. When people ask me, hey, Adam Becker, author of What is Real? The glib answer that I've come up with after, talking about this book for a couple of years is, oh, what is real? Something. And this is a remarkably controversial answer. But yeah, there's stuff. There's a world with stuff in it. And the way that stuff works, it works in such a way that, that it makes the predictions of quantum physics come true. So there is something in the world, something about the world that makes it obey quantum physics to a very high degree of precision and accuracy. Now, what is it about the world? What does it tell us about the world that, that's true? That's the question at stake. Will we ever find out the answer to that? I think we'll get closer and closer. Historically, when there have been competing interpretations of a scientific theory, we were able to either pick the right one or at least narrow it down considerably once that theory was superseded. And usually that either took the form of, oh, well, I used one interpretation of this theory to extend it and come up with a better theory, or I came up with a better theory without really committing to one of these. And then when I looked back at what we had, I was able to say, oh, well, that clearly must be the right answer based on the new theory. So I think that if and when we come up with the next theory after quantum physics, then we'll be able to use that to look back at quantum physics and say, okay, it was this one all along, or it's this weird hybrid, or this one over in the corner that we didn't really think about too much.
So I've been in touch with, because I've been writing these columns for Scientific American on quantum mechanics. I've heard from a lot of people who are saying, you idiots, variations on, you idiots, if you understood my theory, you'd realize that all these problems have been solved. So one person who wasn't quite that rude, one person I've heard from is Chris Fuchs, and who's got, cubism. The reason I bring it up is because there's this persistent idea that I don't think you go into that much, except insofar as you go into the measurement problem. A persistent idea that somehow the solution to quantum mechanics, if there is such a thing, will also possibly solve the mind-body problem. It will explain what connection mind and matter have. And I just wonder what you think about that. Seems like a lot of, there's a lot of activity in that area. Of course, some by cranks and fringe figures, but also by some serious people. So consciousness and quantum mechanics. What do you think? Has Deepak Chopra been right all along?
Yeah. Okay. So here's what I have to say about that. So first of all, I'm a fairly committed materialist. I don't think that there is some special other substance that, that consciousness is made of. I think that the mind arises out of physical processes that happen in the brain and the rest of the body. And actually for that matter, I really don't think it's just the brain. I think that it's the brain and the rest of the body. I think that's an important point, but that's a separate conversation. So given that, there's one sort of very simple sense in which I have to say, well, sure, there's a connection between consciousness and quantum mechanics. We're made of quantum stuff. And so, we're made of molecules that are made of atoms, that are made of subatomic particles that obey the Schrodinger equation and relativistic extensions thereof. And And so, there's got to be a causal chain that you can draw from quantum physics all the way up to consciousness. We don't know quite how to do that yet, but that doesn't mean that we won't ever learn. Which I guess also gives away the game that I'm also a fairly committed reductionist. I certainly believe that there's such a thing as like emergent phenomena that you can't, that on the one hand emerge out of lower levels of stuff in a completely sort of understandable and tractable way. It's not like something magic happens when you get enough stuff. But on the other hand, the phenomena that you get are unexpected, and that there's explanatory power to, talking about these things at a higher level of complexity. Like, there's this old trope, which I think contributes to like the problem of rampant egotism among physicists that, biology is just applied chemistry and chemistry is just applied physics. So it's really all just physics. On the one hand, yes, there's nothing in chemistry that contradicts physics. There's nothing in biology that contradicts chemistry. But does that mean that the best way to think about biology is as physics, and the best way, and that there's nothing in biology, there's no explanatory power that biology carries that isn't in the physics underlying it? No, that's false. So consciousness is connected to quantum mechanics in the same way that, like, I don't know, that like biological niches and evolution is connected to quantum mechanics, right? It's the substrate that it lives on. Do I see a reason for a connection that goes beyond that between consciousness and quantum mechanics? Not really, not, any more than there would be between consciousness and any other field of physics. I don't think quantum mechanics is special in that way. Could I be wrong about that? Sure. Yeah, I could be wrong. There are a lot of smart people who think I'm wrong about that, like Chris Fuchs or, Roger Penrose has talked about this kind of thing in a very different way from Chris Fuchs. But yeah, I would, this is something I'm open to being wrong about, at least in some ways. But yeah, given the problem that we have with interpreting quantum mechanics is not that, oh, it's really weird and there's no way of understanding it, so we just have to throw up our hands and shut up and calculate. That's the opposite of the problem that we have. We have too many interpretations. There are too many different ways of understanding what's going on. And given that there are so many different interpretations, and most of them don't, have to, invoke consciousness as part of the causal chain here. And given the thorny sorts of problems that show up if you do want to invoke consciousness, I feel like it's not a great bet to say that consciousness is involved when there are other ways to get around these problems that don't have these high prices to pay. But bringing it full circle, it's a question of what kind of weirdness you're comfortable with, right? I happen to think that bringing consciousness brings in unnecessary extra sources of weirdness that are not like prices that you have to pay, right? John Bell said something like, the only thing proven by impossibility theorems is lack of imagination. And so, if you take that to heart, then impossibility theorems, so-called impossibility theorems like Bell's theorem, just lay out what kinds of weirdness you're going to have to deal with. They lay out the various logical possibilities and what prices you'll have to pay. Consciousness doesn't really enter into that. You can pay that price and not invoke consciousness. And invoking consciousness doesn't, I think, help you get out of those various sorts of weirdness that you have to pay as the price of these sorts of theorems.
Okay.
So
I think you might be hearing from Chris Fuchs after.
I hope so. I would love to talk with him. He knows that already.
Yeah.
So, yeah.
All right. So one more sort of one big question to wrap things up. I mean, the reason I became a science writer after being an English major was that I think that I thought science was our best hope for understanding the world and understanding ourselves. Mm-hmm. And, obviously replacing religion and even a lot of the philosophical schemes that we've had for millennia. And I've had this growing conviction over time that this goal of making the world comprehensible is unachievable. And it seems to me that quantum mechanics is the great discontinuity in the history of ideas and of intellectual investigation and engagement with the world. It's this thing that is just friggin' weird. It doesn't make sense. And the smartest people in the world can't agree even on sort of the basic terms of the debate in some way. Mm-hmm. And they disagree on whether consciousness has to be part of it, as you were just saying. You've had some of the great experts like Feynman saying that if you say you understand it, that means you don't, and all that kind of stuff. And I'm not sure this is a bad thing for the world to remain mysterious. I think what it means is that we have these aesthetic choices. There are different worldviews out there, and we can pick them because they're consoling to us, or they're beautiful, or they're symmetrical, or whatever. The qualities that appeal to us in the same way that I like the Beatles and you like the Rolling Stones, or Radiohead or something. I don't know. So I just ask you flat out: do you still think that the world will prove to be explicable at some point?
Yeah, no, that's a good question. I guess the short answer is I hope so.
Yeah.
A whole bunch of stuff comes to mind for that. I hope so. I certainly think that there's no reason to throw up our hands in defeat just yet. It is entirely possible that we will at some point, that we will reach something that, appears completely impossible to explain somehow. I don't know. But I really don't think that we're at that point yet. Another thing that people will say sometimes, related to what I was just complaining about, is, you'll hear people say, well, the human mind evolved to understand the world in a particular way, and quantum mechanics is just so far removed from that experience of the world that we shouldn't expect to understand it. And I would be a lot more sympathetic to that if we had no interpretations, but instead, again, we have too many. So there's that. So I'm not particularly concerned about us getting to the point where the world is not explicable anytime soon, but I could be wrong. This is ultimately a question about belief. It's not something that you can, go out and prove, but, so there's this story. There's this thing that I heard that I haven't checked on. How's that?
Sure.
It seemed to be from a reputable source, but it's something that I could independently verify, and I have not. So I'm going to put that out there. Take this with a grain of salt. I read somewhere that Francis Bacon, when writing about, science, in I think the New Atlantis, said, look, we're gonna try this procedure to understand how the world works. And why do we think that this will work? Because God is kind. and God is good, and a good God would make a comprehensible world. Now, I do not believe that there is a God, and I also believe that if there were one, that God would have an awful lot to answer for in terms of kindness and goodness in the world and how it's constructed. But putting that aside, one of the reasons I like that, even though I don't believe in God, is that it points to the fact that, the idea that the world is comprehensible is ultimately a kind of matter of belief and faith. It's not something that we could ever prove scientifically. Even if we had, say that tomorrow someone says, here's the theory of quantum gravity, and you get all sorts of other stuff out of it for free, like dark matter and dark energy, game over. And then say that, for 50 years after that, we keep doing experiments at bigger and bigger particle accelerators and keep looking deeper and deeper into the sky and do all sorts of other things to test its, the new predictions of this theory. And they all come back 100%, even more accurate, even more precise than quantum theory as it currently exists. So say that all that happens. That still doesn't mean that the world is comprehensible, right? Because tomorrow, one more day past 50 years from now, something else could happen, right? That suddenly contradicts the theory. And then it's, we missed something. Crap. So yeah, we're never going to know, even if we think we do know, right? So it's always going to be a matter of faith. Now, that being said, things have worked pretty well so far. And so, betting against science has been for hundreds of years now a losing proposition. So I would not be hasty to do it.
It could be that a kind God would make ultimate truth always something just beyond our grasp.
Sure.
In a way, for I think a lot of scientists I've spoken to, the ultimate nightmare would be finding the theory of everything that makes the world completely explicable and brings to a close the kind of grand adventure of science that brings a lot of the great scientists into this whole area.
Yeah.
This might be the best of all possible worlds, and we can argue about the meaning of quantum mechanics forever. In the meantime, we'll have like quantum smartphones and all kinds of groovy stuff like that.
Yeah. Yeah. I certainly don't think this is the best of all possible worlds.
Yeah.
But yeah, there is a great deal of romance to, the search for ultimate theory of everything. And there is, there's something great to it. On the other hand, there have been many, many times in human history, in fact, more times in more different cultures and different parts of human history, where it was thought that, the theory of everything was had, right? That we understood how it all worked because, it was given to us by Aristotle or the gods or the one God or, or the spirits or our ancestors or whatever, like that there was a different pursuit that drove people in this area. Like I don't know. I think one of the other reasons I like being a science writer and went into this area is that I think about science as a cultural process, right? Science is a thing that people do, like everything else in culture. And so, saying that, science certainly does different things and gives us access to truth in a better and more reliable way. But is it completely divorced from the rest of human culture? No. Is it possible that, the idea of a theory of everything is itself like one of these like culturally mediated artifacts that, in a few hundred years, we're going to look back at it and laugh and say, well, that was just our own prejudices blinding us to the truth. Yeah, maybe.
Yeah. All right. I think we got to wrap it up there. I think that was a great defense of the open-endedness of science. So as somebody who wrote a book called The End of Science, I really appreciate that. Thank you, Adam. Really, this has been great. I feel like we could have talked for another couple hours.
Yeah, no, this has been so much fun. Thank you.
All right. And this will be posted. I just hand it off to the editors of the site, and then they tell me when it's posted, a week or 2 weeks, or I don't know how long it'll be. But I'll send you a link as soon as it's available.
Fantastic. Yeah, please do. When the pandemic is over, I would love to meet up in person. I think I mentioned this over email, but I get out to New York all the time. I'm actually originally from northern New Jersey. I grew up over in Morris County. So I go back there, when there's not a pandemic, pretty frequently.
That'd be great. Stop by Stevens. I'm hoping that one of these days we'll be back on campus. I live, I'm 5 minutes from my office, but I haven't been there in about 6 months.
Nice. Yeah, that makes sense. It's just been such a weird time, but hopefully, it looks like the end is in sight. So.
Yeah. And it looks like I'm not going to see you in Santa Fe.
Yeah, that's right. Yeah. I asked them about that, and they said, we'll be sending out the official word to the people who got it, later this week. Right. It looks like you won't, which is unfortunate, but like I said, I come out to Jersey all the time, when there's not a pandemic. So
I look forward to that. That would be really fun. We can pick up this conversation then.
Absolutely. Okay,
man. Thanks for everything. And, I'll talk to you soon and see you back here one of these days.
Yeah. Thank you. This was a lot of fun.
All right. Bye, Adam.
Bye.